yesterday when we did section 4.3, we were doing division, whether that was long division or synthetic, and finding out factors and zeros, and if they were factors, if they were zeros, and so forth. Today we're actually going to go backwards. So they're going to give us the zeros, and they're going to give us the factors, and we're going to come up with a polynomial. So think about it mathematically what we're going to do. If yesterday we divided to find factors or zeros, today if we're given factors and zeros, what's the opposite of dividing? We're going to multiply. Okay? Yeah. So on this one, what we have to do is we have to just keep in mind when we find those zeros, they come from x plus 2 or x minus 2. And so when we're given the zeros, the sign that's in that binomial is usually the opposite, all right? So let me give you a head start on this, but once I do this one, guys, you'll be good to go, okay? So it says find a polynomial function of degree 3. So it means by the time we're all said and done, we should have x to the third power somewhere in there, okay? Having the zeros of 1, 3i, and negative 3i. So we're going to come up, you can call your polynomial anything. I just call it f of x, but you can call it h of x, cat of x, I don't care. You can call it anything, all right? So we're just going to think backwards. How can we have a 0 of 1? Well, what would our binomial look like? Minus 1 or plus 1 if we have a 0 of positive 1? Minus, right? Because we move it over. Ultimately, how you find your zeros is you take the factor, set it equal to 0, and then solve, right? So then if we have a factor, or excuse me, a 0 of 3i, what's our factor going to be? X minus 3i. Is that okay? And so then what's the last one going to be for negative 3i? Plus. Yep. So they actually want you to multiply it out. So this is just the start. It's not incorrect, really. I mean, this is a polynomial that has a third degree because x times x is x cubed, right? And it has all of our zeros. But what they want us to do is distribute everything. I work on the back part and get rid of my i's first, and so I tend to do that with everyone, even if there's not an I, okay? So what I do is I let the first term, x minus 1, hang out, all right? Then I distribute these, aka FOIL, right? So what's x times x? X squared. What's x times a positive 3i? 3ix. Doesn't that look really weird? What's negative 3i times x? Negative 3ix. And then what's negative times a positive? Negative. What's 3i times 3i? Let's write, don't worry about what the I squared is first, okay, because we'll clean it up in our next line. So we don't have to think too much mental math. Do you guys agree that that'll just be negative 9i squared? Okay? Because ultimately what we're going to do is we're going to have to clean up the 3ix's anyway. So we might as well in that next line figure out, okay, what does an I squared mean and what does it do to that number? So we have f of x equals x minus 1. X squared will be x squared, but what happens with these two middle terms? They cancel out. And then what do we know about I squared? It's a negative 1, but what would a negative times a negative 9 be? Positive 9. And when you see it written that way, it kind of makes sense, because think about if that was your factor and you set it equal to 0, what's the first move you would make? You would subtract the 9 over. So you have x squared equals negative 9. And then you take the square root of a negative. What happens when you take the square root of the negative? The i's, right? So it all kind of makes sense once you FOIL it out and see that. All right, so then the last move, guys, is to distribute one more time, okay? So we'll have f of x, and we're going to take the x times both of these things. So x times x squared will give us x cubed. X times 9 will give us a positive 9x. Negative 1 times x squared will be a negative x squared. And then negative 1 times 9 is a negative 9. Are you incorrect if you leave it that way? No, but typical polynomial fashion is the highest degree counting down until the constant, right? So we kind of like to rearrange them into like the appropriate order. You don't have to. My math lab should take that, okay? Just to make it look pretty though, let's do it in that order. So we have x to the third minus x squared plus 9x minus 9. Is that a third degree polynomial? Yes, and we built it from the zeros of 1, 3i, and negative 3i. So remember what we did yesterday, they would have given us that polynomial, and we would have done synthetic or long division with 1, 3i, negative 3i, and realize that they worked because the remainder would have been 0, right? So we're just going back and forth, back and forth. All right, so the next thing we're going to do is the exact same thing, but this function is going to have zeros of negative 5, root 3, and negative root 3, all right? So let's think about how we build that guy. We'll have f of x equals, how do we have a 0 of negative 5? What does our factor have to be?
Positive.
Yep, so it'll be x plus 5. You all agree? And Corey, if you want to just stop doing that and grab this so you can follow what we did, and I'll let you write down the rest later, okay? So at least you can see the setup of how we set up the other one. Okay, so having a 0 of negative 5 means we would have set a factor equal to 0 and solved and got negative 5. So that means technically it was a x plus 5. What about root 3? What will we have there?
X to the third power. Wait.
Nope. So we'll have x minus root 3. So what we're going to do is just going to take each of our zeros and pair them with x and the opposite sign, right? So how do we have a factor of x minus root 3?
X plus root 3.
And I know what you're doing there, Corey. You're going to see in a second, and it's going to turn to what you're kind of thinking. It's not the third power because that's a square root, but eventually we're going to have a square come out of it. And I know exactly what you're doing. Okay, so what we could do is we're going to multiply. And again, I just do the back two first. Let the first one kind of hang out. So we'll have f of x equals x plus 5. And then we're going to FOIL this. So x times x gives us x squared. X times a positive root 3 is a positive root 3x. Negative root 3 times x is just a negative root 3x. And then a negative times a negative, or excuse me, a negative times a positive is a negative. And then what's root 3 times root 3 going to be?
3.
It's just 3, right? Remember when you square a square root, they undo each other, right? So root 3 times root 3 is the same thing as root 3 squared. So the square and square root undo each other, and you just get 3 there. All right, so in our next line, again, we're going to leave x plus 5 hanging out with us for a second. And we're going to clean this up. What do you notice about the middle two terms? They cancel, and you're left with x squared minus 3. Corey, I think this is what you were seeing, right? In order to have a root 3 as our 0, we would have had to have a square as one of our factors, right? So think about if you were going to solve that, say you set it equal to 0, what's the first move you guys would make? You would add 3 over, so you have x squared equals 3, and then how would you solve for x? Take the square root and put a plus or minus in front, right? So plus or minus root 3. We have it right there. All right, so our one last move is they want us to multiply all of it together. So we're going to distribute this x plus 5 into the x squared minus 3, gather like terms, and put them in the right order. So we have x times x squared is x cubed. X times negative 3 is a negative 3x. 5 times x squared is a positive 5x squared. And 5 times negative 3 is negative 15. All right? And some of you guys might get comfortable enough that when you do that, you can even multiply where the order will happen naturally, okay? But I like to write it in descending order. So we'll start with the cube. We'll add 5x squared behind it. We'll subtract 3x, and then minus 15. And again, thinking back to what we did yesterday, we would have started with that polynomial, and they would have given us the zeros, and we would have had to divide to see if they were zeros or not, and all 3 of them were, so all 3 of them would have a remainder of 0. Okay, so one thing I want you to notice about both 1 and 2, okay, is notice when we had the 3i up here, we also had the negative 3i. And when we have the root 3 here, we also have the negative root 3. And where that's coming from is this term right here when we have the x squared, right? We ultimately get x squared plus something or minus something, where we have to move it over and take the square root. But when you take the square root, what are you always supposed to put in front of your square root? Plus and minus, okay? So anytime you have a root or an I, that means it came from taking the square root. That means you should have put a plus or minus. So if you have one, you have the other. And that's all the bottom of this page is saying, guys. Facts about non-real and irrational zeros. It says non-real zeros. If you have a complex number, a plus bi, where b is not 0, because if b was 0, that would just be a normal number, okay? If a plus bi is a 0, then its conjugate, a minus bi, is 0. Okay, so keep that in mind. So they say, hey, I know 2 plus 3i is a 0. you can turn around and be a smart aleck and say, well, I know 2 minus 3i is a 0 then, okay? So remember, what we're going to do is we're just going to change the sign of that back number, okay? We're going to just change the sign of that back number. And it's the same exact thought process with their rational zeros. If we have this irrational number with a root in it, and we know a plus c root b is a 0, then we know the c root b came from us taking a square root. So what do we put in front of the square root? Plus and minus, okay? So again, we're just going to know that if we have a plus, we have the minus, and vice versa, okay? So we have a little bit of room down there, so I just want to just write some quick examples just so you know what I'm talking about. If 2 plus I is a 0, so is what? If 2 plus I is a 0,
x plus 2 and x minus 2.
not x, because
Oh,
this is
just
the number,
negative
right? 2. So if 2 plus I is a 0, what's the only thing we have to do to that number?
Make it a negative.
Make it a negative. And not the whole number, but just the I part, right? The imaginary part. So if 2 plus I is a 0, so is 2 minus I. You guys got it. So that's kind of the imaginary number. Now, if 3 minus 2 root 5 is a 0, it,
3 plus 2.
you got it. And again, it's the whole idea of where I is coming from is because we took a square root of a negative, and where the root's coming from is because we took a square root of a non-squared number, right? So is 3 plus 2 root 5, okay? And the reason why I'm pointing that out is because we're going to start building these, and you almost get stuck. You're like, what do I do now? Well, you know if you're given 1, you're actually given 2 zeros. So kind of keep that in mind as we move forward. So let's go ahead and work with the second page. So it's kind of a hybrid of what we just did 5 minutes ago and what we did yesterday in 4.3, okay? So they're going to give us a polynomial function, but they're only going to give us 1 0. We actually have to take that 1 0, divide into the polynomial, because remember that's how we find our zeros. We're dividing, right? So that's like our starting point. We're going to take that 1 0 and divide into our polynomial and get a reduced polynomial that we can either factor or solve using the square root method or whatever it may be to get our other zeros, all right? So keep in mind what we know about polynomials. If it's a third degree polynomial, how many potential zeros does it have? 3 of them, right? And right now we are only given 1. So we're going to use that 1 to find the other 2, which almost seems magical, right? So remember when you're given the actual 0, he is who you divide by. You don't change the sign. So -5 will go up on the shelf, okay? And we have all of our place values accounted for, cubed, squared, first power, constant. So we'll just do 1, 5, -2, -10. So this is kind of a good review of what we did yesterday. Okay. Yes, it will. All right, bring down the 1. All right, so multiply, throw it on the line, and then add, right? So what's -5 times 1? -5. So that will be 0 because we're adding. What's -5 times 0? 0. But then add, you'll get -2. What's -5 times -2 is +10, and what do we get for our remainder? 0. That should not be a surprise, right? We were told it was a 0, so we know the remainder is a 0. So what exactly is happening, guys? We have made the function look like this. X plus 5 was one factor. Where did x plus 5 come from, guys? What were we told? We were told the 0 was -5, so that came from a factor of x plus 5, correct? And when we divided him, who's the new polynomial that came to be? Well, we went from a cubic, so this is actually now a second, right? Do we have the middle term at all?
No, it's just a 0.
Just a 0, and then that's just -2. So this is kind of like what I was trying to get us to do yesterday. Think of your polynomial as this divisor times the quotient plus the remainder. Remember, but we didn't have a remainder. So what we need to do in order to find our zeros is we set each of our factors to 0 and solve. Do I need to set him to 0 and solve? No, because we already did it. But who do I need to set 0 to solve? X squared minus 2 equals 0. how am I going to solve that guy when there's no middle term? We can use the square root property. What's the square root property says? Isolate your square. So what do we need to do? Add 2. Take the square root. And what I'm going to put in front of my root? Right? So what does x end up being? Plus or minus root 2. So even though they gave me negative 5, I know my other zeros are what?
Plus square root 2 and minus.
Yep. And is that a surprise? No, because remember, if you have one root, you're going to have its conjugate, the negative root. So notice we did what we did before. That was not a surprise that it was 0 because we knew it was a factor. But what we're doing now is we're taking our quotient and breaking it down further, which we didn't do that yesterday, right? So we took our quotient, x squared minus 2, and we factored it, okay? Let's see if we can do the same thing right here. We have a polynomial to the 4th degree, so at most, how many zeros does it have?
3.
4. Turning points is 1 less, okay? So all of them will match. So how many zeros or factors you have is the actual degree, and then the turning points is the 1 less, okay? So we have this polynomial x to the 4th minus 5x cubed plus 7x squared minus 5x plus 6. Oh my gosh, that's a mouthful. All right, and one of our zeros is negative I, okay? So this is actually going to take us a couple rounds because we only have 1 and we still need to find 3, okay? So right here, leave room for 2 synthetic divisions, okay? So I'm gonna use the first part and then I'm gonna use the second part. All right, so remember when you're given a 0, you don't need to change the sign. And since we're dealing with i's, we're gonna space out our coefficients a little bit. All right, what's my first move?
Bring the 1 down.
Bring the 1 down. Once you have that 1 down there, it's multiply, add, right? So what's 1 times negative I? Negative I, there's no trick there. What's negative 5 plus a negative I? Negative 5, negative I, right? They're not like terms, so we can't combine them. And then this is where some of you guys might opt to use your calculator. Some of you guys are kind of doing it in your head with me. So what we're going to do now is we're going to take negative I times negative 5 to get a positive 5I. And then negative I times negative I is a positive I squared. But what's I squared? Negative 1, okay? If you put it in your calculator, they're always going to flip the order. They're always going to have the real number part first and the imaginary part second. So in your calculator, you should get negative 1 plus 5I. And that's the same thing. Did you get that? So
Multiply negative 5.
okay, so in parentheses, or actually negative I on the outside, but in parentheses, you need to have negative 5 minus I. Because you have to tell your calculator, I want to multiply negative I by both of those together.
Hold on, I'm going to do this again. So,
I just want to give everyone a chance to get what that was.
how do you do that on the calculator?
Are you okay with where the I is? Like,
Yeah.
Okay, so clear out your calculator. Type negative I, parenthesis, like not including the I, right? So we're going to start our second chunk. Negative 5 minus I, close off your parenthesis.
Negative 1
Plus 5I, yep. So they'll always do real number, imaginary. That's technically the order you should be writing it, but the reason why I did mine is because I'm doing it by hand, right? So I'm just doing it in the order that I do it. Negative I times a negative 5 is a positive 5I, and then negative I times negative I is a positive I squared, which is negative 1. Okay, and at that point, when you have that in your calculator, you can just go ahead and put plus 7, and it will do that math for you guys. That will be 6 plus 5I. See if that's what you get. So if you were to have that in your calculator, you can just hit plus 7 behind it. So it'll take your answer and add 7. All right, is that okay? And then we're just going to start over again. We're going to take that value times negative I. All right? So in your calculator, just put answer times negative I. Or if you're doing it by hand, do it with me. Negative I times 6 is negative 6I. Negative I times 5I is negative 5I squared. But I squared is negative 1. A negative times a negative gives me a positive 5. Ultimately, these two end up canceling. I'm just left with negative 6i. Those that are doing it in your calculator, did you get negative 6i when you did that?
Yeah, I did. I got 5 minus. Well, if you flip it, it's still negative 6.
Right, so 5 minus 6i, and then the 5 and the negative 5 would cancel out to leave you with that negative 6i. Okay? And last but not least, negative times a negative gives us a positive 6i squared. But I squared is negative 1, so it's really a negative 6, which gives us a remainder of 0. Not a surprise. Not a surprise. We knew it was a 0. But this is what I'm talking about. We just came up with coefficients of our next polynomial. Look how ugly those coefficients are. How are we supposed to put those in and try to factor them? We don't. We have to keep in mind, if we know that negative I is a 0, so is what? Positive I, right? So what I can do is right below this on my shelf is divide by positive I with those ugly coefficients, but then that will kind of knock out all of our i's, and we'll be left with real numbers that we can factor or use the square root method with, okay? So just pull down those coefficients that we just found, kind of leave the gaps, right? Negative 5 minus I, 6 plus 5i, negative 6i. We don't worry about that. And we'll have the line, bring down the 1. And guys, this goes a lot cleaner because the i's will start canceling out. So what's I times 1? Just I, right? I times 1 is just I. What's going to happen with this positive I and this negative I? They're going to cancel, so you'll just be left with what? Negative 5. All right. Well, what's I times negative 5? Negative 5i. That's no surprise, right? But what's going to happen with that positive 5i and that negative 5? So things will get really clean, okay? And that will leave you with just what? 6. But what's 6 times I? And what's negative 6i plus 6i? 0. Okay? So we know so far, I'm going to write it up here. I know it's kind of ugly. We know two factors already. We know that x plus I was a factor because they told us negative I was a 0. And since negative I was a 0, so was positive I. So what's another factor? X minus I. And what did we come up with, guys? We just came up with a new quadratic, okay? The question is, what powers go with that quadratic? Well, what did we start with? What degree? Fourth. So when we did it the first time, it reduced this to a third degree. So what are we sitting at? You got it. So we'll have x squared minus 5x plus 6. Is that all right? X squared minus 5x plus 6. So we used the fact that we knew negative I was a 0 to find another 0. Positive I. So we got kind of factored, right? So if I want to find my other zeros, do I need to worry about x plus I or x minus I being set equal to 0? No, we already know those are some of our zeros. Who do we need to set equal to 0 and solve? The last one. So when you get a quadratic like this, sometimes it's factorable. In this case, it is. Sometimes it's not, so sometimes you have to use the quadratic formula, and that's okay. That's why we know about the quadratic formula. So we're just going to worry about x squared minus 5x plus 6 being equal to 0. What are factors of 6 that add up to negative 5?
5 and 1. Wait, no. 6 times 1.
Okay, so 6 and 1 will multiply to be 6, but 1 would have to be positive and 1 would have to be negative to get to 5. But if one's positive and one's negative, it wouldn't multiply to be a positive 6. So what's another way 6 can split up?
3 and 2.
3 and 2, right? And they're both what kind of signs?
Negative.
Negative and negative, okay? So I'm going to just kind of shortcut it. Is that okay? Can I just give you the factored form? Whenever your a is 1, remember the shortcut is x minus 2, x minus 3. It's just your factors. So what does that mean for our zeros? What are some additional zeros we have? 2 and 3. Okay. So on my math lab, what are they going to want you to list? They're going to want to list every zero but the one they gave you, right? So what one did they give us way up here? Negative I, but we used our smarts to figure out the other 0, I. So my math lab doesn't know that you realize that, right? So that's still like a new 0 that you need to put in, okay? So all the other zeros,
So it'd be 2, 3, and I.
you got it. So kind of keep that in mind. Anytime you use the conjugate, whether it's an imaginary number with I or a root number, my math lab does not realize, oh, they use that to get their other answers. You know, like you have to say, oh, I knew negative I was one of our things.
But you have to put it in.
You still have to put it in, yep. Because really all my math lab gave us was just one of them. We used our smarts to know that that was another one, because it was that rule that we just talked about, right?
Opposite.
The opposite rule, the conjugate. Okay, so this next one's basically identical to that, guys, except for the remaining quadratic that comes out of it is not factorable. So we just have to use the the quadratic formula, okay? So what's the 0 they give us? 4, so we'll leave 4 alone. And we have cube, squared, first degree, constant, so everything looks good there. So we'll have 1, -6, 13, -20. Bring down the 1. 1 times 4 is 4. -6 plus 4 is -2. 4 times -2 is -8. 13 plus -8 is 5. And 5 times 4 is 20. And again, that should always happen, right? It's a 0. So if you do it and you get a remainder, you're like, crap, I did something wrong. Know that this will not be right, okay? So what have we done? Again, I'm going to kind of just come over here and write our polynomial in factored form. It's f of x equals x minus 4. That was one of the factors because they gave us a 0 of 4. And then what's our remaining quadratic, guys? X squared minus 2x plus 5. So see how kind of redundant we are? We use the 0 to get a smaller degree polynomial, and then that degree polynomial will either be able to factor or use the quadratic formula or the square root method, okay? So do we need to set x minus 4 equal to 0 and solve? No, that would just give us a 0, 4. We know it. So who do we need to set equal to 0 and solve? X squared minus 2x plus 5 equals 0. Don't spend too long on it because, like I said, this one's not factorable. But I always run it quickly through my head because if you can factor, it's usually the quicker way. Factors of 5 that add up to -2, they don't exist. 5 only splits up as 1 and 5. So you maybe can get 6, you might as get 4. What did you say?
You have 3 minutes left.
Oh, thank you. Okay, so if I get cut off, what we're going to do is we're just going to use the quadratic formula to solve to get our other two zeros, okay? So we have x equals -b plus or minus square root b squared minus 4ac all over 2a, where our a is 1, our b is -2, and our c is 5, okay? So this will be a positive 2 plus or minus -2 squared minus 4 times a, which is 1, times c, which is 5, all over 2 times a, or 2 times 1. I don't worry about the square root. I do everything under the square root first, and then I worry about breaking it down later. So let the 2 plus or minus hang out, and then in here, just do this math real quick, and you get -16 over 2, okay? And I just put it in my calculator exactly like that. -2 squared minus 4 times 1 times 5. This ends up being 4 minus 20. 4 minus 20, -16. Once you get your root, break it down, whether it's a perfect square or whether it's not. What is the square root of -16?
4.
Not just 4, but
-4. Oh, 4i?
I, right? I is there. So this is actually x equals 2 plus or minus 4i all over 2. 4 because the square root of 16 is 4. And I because it was square root of -16, right? And then what's the last thing we can do? Are all three things divisible by 2?
Yes.
Yep. So this is really 1 plus or minus 2i. Is that okay? So our other zeros are 1 plus 2i and 1 minus 2i. And doesn't that meet what we were told? If you have one, you have the others.